Today, I would like to discuss an extra credit opportunity provided by Dr. B. Unfortunately, I did miss number 5 on our exam, but let's just get into it so I can gain these points. You sell TVs. Your sales figures are as follows. So in 2017, you have 12 million. In 2018, you have 14 million. In 2019, you have 11 million. And in 2020, you have $19 million, respectively. You decide to use the simple mean forecast method. You are very concerned about the over forecasting. What is the value of the appropriate accuracy metric to assess the forecast accuracy of this model? Round to the nearest whole $1 million. Okay, so as we can see, we have the year, the sales figure, and simple means just put up in a table so you can see it a lot clearer and know where we're going to be putting this information. So, because 2017 had no prior data, I went on ahead and made that note just so no one else would get confused the way that I did. And if we were to put this into a calculator, we would put 12 plus 0 over 1. The 1 indicates the year that we're analyzing. So because there isn't more than 1 year, we would go ahead and just divide 12 by itself. And that's how you got 12. 12 plus 14, obviously you're going to get 26. And then after you divide that by the 2 years that you're looking at, you are going to get 13. And so on and so forth. So whatever average that you would get within the numbers that you used is what you're going to use. And as you can see, our last number is 14, and this is because I added all of the 4 numbers up and then divided it by 4. Now, this is where the tricky part gets me, and I think this is where I lost most of my points. Your next step would be to find the errors, and the errors are pretty much where either the company or the individual that made the projection for the year, it faults between that and the forecast and their actual numbers. So for example, again, for 2017, we're going to leave that empty because there was no prior year to analyze this information based off of. But you can take 2018's numbers by looking at 12 and 14, and you get positive 2. And then if you follow along, you do see a negative number, but we'll cover that in a second. I know this slide may seem a bit daunting, but hold on and hear me out. This is essentially all of the implementations of the errors that we just found. So MAD, CFE, and MSE. With MAD, you would essentially take the absolute value of the numbers and divide it by the periods that you're using. So in our case, we would take 2, the absolute value of -2, which is 2, and 6.66. After adding that up, you would divide that by the periods that we have, which are 3 that we're analyzing, and our total comes out as 3.55. With CFE, we would have all of the numbers as is. So we would take those numbers and add them up, and that's all. 2 minus 2 gives you 0, and then you're left with 6.66. And with MSE, you would take the squared amount. So 2 squared, and 6.66 squared. Now that number, 52.35, is very different from the other ones, but that's how you would do that. And after adding them up, that's how you would get 52.35. And the question was, what would be the best in the case of over forecasting? And so if you move on to the next slide, you can see that 6.66 was the better answer, and that happens to be in the CFE category. Thank you so much for listening.